Hello, and welcome to this last breakout session of Build. You all made it. Good job. So I hope you all had an amazing time and got plenty of learnings around AI. Here we won't talk much about AI because we'll be talking about security and especially how Microsoft secured its engineering system. My name is Carl Pitera, and I'm a group product manager in OneES, which stands for One Engineering System. And my team works on the security guardrails to help Microsoft engineers improve security while minimizing toil. And I'm here today with my colleague, Rajesh.
Thank you, Carl. Hello, everybody. I'm Rajesh Ramamurthy. I lead the product team driving the platform capabilities in Azure DevOps, covering areas such as identity, auth, billing, infrastructure, security, and compliance. And our team's charter is to ensure that Azure DevOps remain secure, scalable, and resilient for our customers.
OK, so let's take a peek at our content for today. So we'll start with some context about how we're organized to tackle the engineering system of this massive group of internal developers that is Microsoft. And you'll see the type of scale at which we operate. Then we'll share some background about the threat landscape that our industry is facing, and more specifically, what Microsoft needs to defend against. This will lead us to the creation of the Secure Future Initiative and its key principle. And if there's one thing I need you to remember today, it's those principles. So we'll take some time detailing them. And then, in the main course of the session, we'll talk about security moments, because that's how we see things. It's how we can introduce security at the right moment all throughout the DevOps lifecycle. And by the way, in this presentation, we will be focused on everything that happens between coding and right before the release. So like a good product manager, I want to start us off with who my customers are. It's the Microsoft developers. And there's a lot of them. As you can see, more than 150,000. And they produce a lot, more than 5 million commits, more than 15 million builds per month. That's really a lot to deal with. And we also have to deal with repositories, with thousands of small repositories to tackle a specific product or a specific tool, up to a few very large monorepos for large product lines like Windows, Office, Azure, etc. And it would make my job much, much easier if everybody was doing the same thing. But the reality is they don't, right? Like every tool, every product is doing something different. So we have to adapt, and we have to find the right common denominator of all these teams, all these products to have the right security. So with that scale in mind, we have to divide and conquer. And we've improved our process over the years, building the OneES core platform, which is what you see in the middle of the pyramid here. That platform is really the common denominator for all the things that has to happen for the company. It's built on top of the retail products that you all know and love, Azure DevOps, GitHub, Visual Studio, VS Code, and more. And then we basically enhance these retail products, especially having in mind security, performance, and scale. And then product teams, specifically for their needs, will introduce some customization, additional tools, and the things they need. Once we've all done that, if there are any innovation that we can bring back to the market, we will do that. That's how, for example, we released GitHub Advanced Security for Azure DevOps or Managed DevOps pools. So now that we've established broadly how we worked, let's take a look at the landscape that guides our decisions. And in recent years, we've seen a complete shift on the threat landscape, going from specific software exploits to attacks and vulnerability in the supply chain. I'm sure you recognize these names and heard a lot about these threats. And their particularity is that they were across the DevOps cycle and attack specifically the supply chain. And the specificity of that is that it impacted both a lot of customers and the entire industry. And this led us to a much more costly impact of that. And so there are really two things that we can do for that. The first is going through the entire DevOps cycle and looking at each moment where we can do something. And the second is shift left. And I can tell you shift left is not a buzzword. It's something we practice every single day when we make our decisions. Because the earlier we find and prevent an issue, the easier it is to fix and the less it costs. It's best for us, it's best for our developers' life, and it's best for our bottom line. So now that we've seen the landscape, let's take a look at what we have to focus on at Microsoft. To you, Rajesh.
Thank you, Carl. As defenders of one of the most targeted digital estates in the world, we're seeing these threats up close every single day. And when incidents like this happen, we respond with transparency and move quickly to mitigate the threat and to protect our customers. I'm sure that if you have been following the Microsoft security blog, yesterday Microsoft published a blog post about Luma stealers. I'm sure that all of us have heard about infrastructure as a code, software as a service. This is the first time that I have actually seen somebody provides malware as a service. So that's the kind of threats that Microsoft and our customers face every day. Now, I'm sure that many of you have already heard about this, but let me give you a quick recap. The Secure Future Initiative, or SFI as we call within Microsoft, is a multi-year, a company-wide effort to fundamentally improve how we design, build, test, and operate software, with security at the core. We launched SFI about 18 months ago based on the insights from the global threats that we see every day and from our own incidents. One thing was very clear. The threat landscape isn't just changing, it's actually becoming more aggressive. To tackle that, we need a stronger and a more proactive approach to stay ahead of the evolving threats. And SFI is our response to this challenge. Across Microsoft, all of our principles, all of our work is now guided by three key principles. Secure by design, where security is built in from the start. Secure by default, where protections are turned on by default with no extra work needed. And secure operations, where we keep improving our controls and monitoring to stay ahead of these threats. We'll dive into each of these principles in a bit. At the heart of the Secure Future Initiative, or SFI, is a simple principle: security above everything else. SFI is a framework that's built around 6 key security pillars, with dedicated teams across Microsoft driving progress across each one of them. In this particular session, we will focus on one of the pillars that you are seeing there, which is the Protect Engineering Systems pillar. And we will walk through how we have secured Microsoft's own engineering system. For the next few minutes, we're going to talk about how we put these core principles, secure by design, secure by default, secure operations, into action to protect and strengthen our engineering system. So let's start with secure by default, or what we call start right. But what does that really mean? Well, it means when we design or build a feature or a security control, it is secure right out of the box. Developers shouldn't have to guess what the right security settings are. We provide secure defaults across the company so that engineers can stay focused on building great solutions. without having to worry about how to secure their systems. And that's what we mean by secure by default. Once you start right, the next step is to stay right. That's the idea behind secure by design. You will hear us today throughout this presentation using the words start right, stay right, get clean, stay clean, get secure, stay secure, because these principles guide everything we do at Microsoft. Now, secure by design means it's not just about starting in a secure state. It's about making sure that it remains secure throughout the life cycle of the feature or a system. We design things in a way that it makes it difficult to drift from that secure baseline. If it happens sometime, we catch it quickly, and we bring it back on course. And that's what truly embodies secure by design. Building security in a way that lasts, not just at the beginning, but all the way through. Now, what we mean by secure operations. Secure operations starts with locking down our DevOps control plane. Systems, tools, and services that our developers use to code, build, test, and deploy software and services. That includes our repositories, our pipelines, our agents, our artifacts, feeds, environment configurations, essentially the core of the engineering ecosystem. Why is this important? Because if a malicious attacker gains access to the control plane, one, they can inject malicious code into the software supply chain, steal credentials or secrets used in pipelines. They can tamper with build artifacts, or worse, using all of this, they can gain access to your production systems. That's why secure operations matter. Our goal is to protect access to the engineering system and the entire supply chain, reduce the risks from plain text, leaked, or overprivileged credentials, and enable continuous monitoring to stay ahead of the evolving threats. How do we do that? How do we bring security into each stage of the DevOps cycle? First, we start by enforcing policies before and during code commits, especially if you are committing code to a protected branch that ships code to production. We run deep security scans during the build and test phases. We apply critical checks and safe deployment practices when deploying changes to production. And finally, we continuously collect data and monitor for anomalies so we can detect and respond to threats quickly. With that, over to you, Carl.
Thank you. OK, so if you remember one thing today, secure by default, secure by design, secure operation, and the right security at the right moment. Speaking about moments, you remember when I said that my team works on security guardrails to improve security while minimizing toil? The way we do that is by thinking of it in terms of security moment, which is observing the DevOps lifecycle and really putting ourselves into the shoes of our developers who are going to use all these tools, and how do we introduce the right security at that right moment without them having to be security experts, right? Because we're not all those security experts, so we have to introduce that in a way that they don't even have to think about it. So the basis of any solid security system starts with inventory. And we have to know the assets we have, who owns them, and the potential impact that they can have on production. So anytime an asset is created, or if something changes, we want to ensure that our inventory is accurate. And this is our first opportunity to apply secure by default and secure by design. So we have that tool that we built in the OneES core platform called StartRight, where anytime a developer wants to create an asset, a repository, a pipeline, and more, we will ensure that we collect the right metadata for this asset. Let's see it in action. So we have here our famous Contoso project, and our developer wants to create a new project here. And so we have this tool, as I mentioned, called StartRight, where very easily we can provide a few data about the repository itself. And as you can see, it's extremely close from the normal experience of creating a repo. So let's call it my great super repo here. In StartRight, we can provide quite a bit of metadata information. And here, for example, I can share what package manager this project is going to use. That allows us to do a bunch of things in the background, like preparing the right feeds, making sure that we have the right scope of open source packages we're going to use. So let's say here today we're going to do NuGet, and then we can classify this repository. And this will have an impact on the policies, on all the things that happen in the background for that repository. So let's say I want it to be a production repository, and then I need to tell who are going to be the owners of that repository. So that's still my Contoso here. And in just these few steps, I have defined all the properties of my repo, and in the background, this will allow us in OneES to collect all the core properties. So beyond that, we can also create pipelines, and it's a very similar process where, as you can see, this works for Azure DevOps and GitHub. Here, I can use my new repo that I created, and of course, I have a bunch of these. Again, I can define whether that's a production or non-production, and we have the ability to have pipelines that remain non-production, even for production repo if they are like on some user branch or things like that, or define production. So here, again, I'm defining as production. I can configure it with a starter pipeline that is predefined with templates that we'll see later, or have an existing YAML. So I can go through these steps. As you can see, super guided, extremely easy for our developers. They don't really have a sense that they're building on security features here, but that's what happens. And that's the magic that we want to create. So once we've created and collected that initial inventory, of course, we need to make sure that the inventory stays accurate. And so we have processes that happen, again, in the background and mostly without any developer involvement, where we do a lot of cleanup. So we check for meaningful activity. If there's no meaningful activity, we clean up those assets. Super important. We don't want to have things lying around because they're ripe for abuse. And then we disable assets which don't have the right metadata, meaning owners potentially have left the company, changed teams, things like that. If something's wrong, we disable so that, again, we reduce the attack surface. And we revise constantly access to production and whether any of these repos, pipeline branches have interactions with production to make sure that we have the right classification and the right metadata and that the right processes are happening in the background. And we're going now to see a very, very important aspect of security, which is credentials.
Thank you, Carl. So let's talk about a challenge that we're all familiar with, credentials in code. See, it's a common problem across the industry, right? Something most of us have encountered at some point of time. Hard-coded secrets, tokens, connection strings, they're really convenient to use, but they pose serious security risks, especially when you put them in code and the code is shared widely with your team or worse across the entire company. Leaked secrets are one of the most common causes of security incidents, especially when they are left exposed or unprotected. Now, as the number of secrets grows, managing them becomes only harder. Carl kind of gave you a glimpse into the scale at which we operate here at Microsoft. So it's natural that we have a lot of credentials at Microsoft. So it is a very important challenge for us to address. Now, these secrets, they can include anything from Entra application client secrets to personal access tokens that you see and use in Azure DevOps. So to reduce the risk, we have focused on eliminating the use of plain text secrets as much as possible. For our workloads running in Azure, such as VMs or containers, we have transitioned to using managed identities, removing the need to store and manage credentials altogether, closing off a major threat vector. Of course, we understand that migrating away from plain text secrets can be done overnight, especially when you have a lot of them. So in parallel, we have invested in traceability, making it easier to detect exposed secrets at scale. And if we do find them, we will quickly go and revoke them. Now, it's not enough to find and remove the secrets after they have been committed to the code. We need to stop them from being added in the first place, right from the developer's machine to your remote branch. And this is where GitHub Advanced Security comes in. Its push protections feature, it scans for secrets in plain text files, and if it finds some, it blocks the commit so that these files with plain text secrets, they never reach the remote branch. And with our improvements to the personal access token formats, making them more easily identifiable, the detection is now much faster and detection is more reliable. Now, you have heard from me about the security challenges that comes with using plain text tokens and secrets, especially personal access tokens, something that if you're using Azure DevOps, you're all familiar with. We call them PATs in Azure DevOps. So how do you remove these PATs completely? Well, as I said, right, you do have some secure alternatives today, like managed identities or service principals. So instead of using user accounts and creating a personal access token for that user account, you can migrate to using managed identities or service principals, especially for apps and tools that integrate with Azure DevOps. Second, you can configure the Git credential manager to use Entra tokens instead of PATs. There are a couple of configuration settings that you'll have to do, and that will increase your security multifold. And to further support this transition, we have removed the usage of PATs from common flows such as cloning a repo. If you're trying to clone a repo through our Azure DevOps web experience, we are no longer creating PATs as part of that. And then we have also introduced a new policy that is available to everybody today that allows organizations to completely block the creation of personal access tokens. So let me show you a quick demo about that. All right, here is my organization. I'm sure that if you go to the organization settings policies, now you will see a new policy called restrict personal access token creation. So right now the policy is turned off, which means I am free to go create a personal access token. So I'm just going to go do that. All right. Perfect. I was able to create a personal access token now. Now what I'm going to do is I'm going to go turn on the policy. Now at this point of time, since I have turned on the policy for this organization, anybody in this organization's ability to create personal access tokens is completely blocked. So I go, let me try to do that again. Well, now you can clearly see the new token button is disabled, and I get a message that clearly says, hey, your ability to create paths is completely blocked in the organization. Now, sometimes, especially, a company like Microsoft, where we have a lot of apps, and these apps rely on paths, it takes a while for us to burn down those apps. So that's why, to allow a phased burn down of paths, we created the allow list capability. So what I'm going to do is, if my app requires a bit more time to be able to migrate away from paths, then you can still turn on the policy at the organization level, but exclude my account from still doing paths, because I needed more time. So what I'm going to do is, I'm going to go turn on the allow list, and I say, hey, let me add myself to the allow list. So I'm going to add myself. Oops. Add to the allow list. Sounds good. I'm going to go refresh again. Well, as you can clearly see, the message went away. The new token button is enabled again. So let me do that. Now I can go create the path. Now, as you notice, right, we have released policies to govern the usage of paths across the company a couple of years ago. And at Microsoft, we use those policies. As you can clearly see, right, my ability to create full-scoped global personal access tokens is disabled. Even if I want to go create a personal access token, even if I am in the allow list, guess what? I can only create a personal access token with a specific scope, not a global scope or a full scope, a credential that has much wider access. As part of hardening our control plane, we have also made several key security improvements to strengthen our overall defense posture. First, we eliminated persistent access to privileged groups such as project administrators, collection administrators. As you're all aware, membership to these groups, members of these groups can perform high privileged operations in their Azure DevOps organizations. Instead, we now use just-in-time access via PIM groups. PIM is Privileged Identity Management Groups in Entra. Users needing access to these privileged groups, first, they need to be part of an entitled group. Second, every time they need access, they need to request access, and that request has to be approved. Even if they get that request approved, that request is time-bound. They don't have persistent access to these privileged groups anymore. Second, we no longer use our regular identities, especially for privileged access in Microsoft. Instead, we have created what we call alternate identities or alt accounts for privileged operations. These accounts have much stronger authentication requirements, such as using smart cards or external security keys, such as YubiKeys. And as always, our GitOps systems continue to monitor these groups, and if they see any direct addition to these groups, they will go remove that. Sorry, go.
OK, so we've looked at a couple of key moments where we can introduce some security. Definitely, inventory is an important one. Managing credentials is really critical because that's a very important attack vector. Let's look at open source consumption, which is another one. And in the threat landscape that we saw earlier, that was one of the important vector of attack. So let's start by thinking what start right means from the open source consumption side. So for us, it means basically avoiding the consumption of a malicious package, something that has been tampered with, typo squatting, or a package that is known to be vulnerable already. So in order to achieve that, what we're doing is that we have a private feed, and we don't consume packages directly from the internet. And so You saw me earlier in Start Right selecting what package manager I wanted to use. That's how we set up that internal feed in the background without any operation from the developer in order to be able to set that up. And that way, that allows us to scan all those packages for malicious software, check whether they have typo squats, and of course ensure that they are not already known to be vulnerable. The other added benefit of that is that it allows us to be isolated from the internet when we are consuming these packages. And we'll see later when we talk about build that this is another very important property of our engineering system. But thankfully, the vast majority of packages are not malicious and they are not known to be vulnerable when we start consuming them. However, the real challenge is that later, we use a package, it's great, everything's great, but later they become known to be vulnerable because a security researcher, a hacker, found some vulnerabilities. And so we have to constantly monitor for vulnerabilities of packages, and we have to drive the upgrade for that. So in order to help with that, we have a system that's extremely close to GitHub Advanced Security together with Dependabot, where we continuously monitor all the CVEs, detect what packages are in use, and if there's a match, then we alert our developers and we help with remediation. So both Dependabot and we also have a system that's pretty close to GitHub Copilot AutoFix in order to help with those remediation. And that's something that will drive at scale with the company. Okay, so again, super important topics along the DevOps life cycle, inventory, credentials, and open source. Now, let's talk about another of these interesting moments, which is pull request. Pull request is a great time. It's a time when a developer is asking for feedback from one of their peers. So a time where they're open to feedback, but also a time where most of our code goes through some checks and verifications. And so it's a great time for us, from the security perspective, to introduce some more of that invisible security or something that will not have too big of an impact on the toil. And so we use a very highly scalable PR policy system based on GitOps principles, with policies defined as code that are automatically enforced at every level, at the company level, so enterprise, organization, project, repository, and it's all managed by our GitOps platform. So it's secure by default because we have a company level, a company standard that applies everywhere, and then it can be further refined on the level. And it's secure by design because any modification to the policy is immediately caught, and if it's not more restrictive than the company level, it will be rolled back and changed. So the example you see here on the screen is one of those policies that we use, which is all about checking that a pull request has at least 2 full-time employees reviewing it. It defines the scope of application, so what are the repositories targeted, what branches are targeted, how many reviewers we want, and a bunch of metadata. So we have a certain number of these policies that are constantly running. As I mentioned, we have a bunch at the company level, which are defined systematically. And then as we go down the levels down to repositories, our users, our developers can further refine them to be more restrictive and be more secure. Another aspect is protecting those PRs, and Rajesh will walk through how we do that with proof of presence.
Thank you, Cole. We have introduced another important security measure across Microsoft, especially when you are merging code into production branches from which code directly ships into production. It's called proof of presence, or simply we call POP. proof of presence requires that each pull request be attested by a human being using an authentication method that confirms their physical presence. If this attestation isn't completed, then your PR is not merging into that production branch. So how did we do this? First, we created a new branch policy called proof of procession. And then we used our GitOps system that Carl was talking about to first turn the policy on and make sure that the policy is turned on for the several thousand production branches we have across the company. We have around, last I checked, 62,000 production branches across the company. And with the GitOps system, we also ensures that not only the policy is turned on automatically for all of the teams across the company, they continue to stay turned on. If somebody tries to go turn it off, guess what? Our GitOps system will catch that and will reset it back. Now, to meet the POP requirements, every PR must include a real-time authentication. This can be done by the PR author or somebody within their own team, using a just-in-time multi-factor authentication. This typically involves using a FIDO2 compatible authenticator such as Windows Hello for Business, where you're using biometrics such as your Face ID or your fingerprint or your pins to authenticate. Or in some cases, you can also use external security keys. We require external security keys such as YubiKeys to be able to provide this authentication. Now, the reason for enforcing proof of presence on Microsoft is, one, this ensures that credentials such as personal access tokens or even stale Entra tokens, even if they are older than few minutes, they really cannot be used to merge code into a protected branch such as the production branch. Using proof of presence is significantly helping us to reduce the overall threat surface. Now, this capability, unfortunately, is only available to Microsoft at the moment, but we hope to we are working hard to bring the same capability to all the customers soon. So let me show you a quick demo about how proof of presence works. All right. So here is the new proof of presence branch policy. As you can see, the branch policy is turned on, and the enforcement is required. And this is how all the 62,000 production branches that we have across the company, they all have this proof of presence policy turned on and required. Now that the policy is turned on, so what I'm going to do is I'm going to go and quickly go make some change. So let me. All right, so what I'm going to do is I'm going to go edit this file. I'm going to commit to, since I can't directly commit to the main branch, I'm going to commit to another branch. And then what I'll do is I'll go create a pull request. Okay, now I have a pull request. I'm going to create that pull request. Now, as you can see, clearly that since I have turned the proof of presence policy on at the branch level, for me to merge from this branch into main, I need to provide the attestation for proof of presence. Now, what happens if I try to do that? Like, let me see if I try to, yeah, it's now telling me that I can't actually do that till I complete the attestation. So what I'm going to do is I'm going to go do the attestation right now. Okay, now it's asking me to confirm with biometrics. Okay, I'm going to use my fingerprint in this case. Now the policy is satisfied. Now I'm able to approve this. Complete the PR, complete the merge. It's all done. Perfect.
Thank you.
So another great moment to introduce security is build and release. It's a time where we have plenty of compute, although we need to be careful not slowing down our builds too much. But it's time where we can run static analysis, like CodeQL, for example, a bunch of analysis tools that we run in the company. But it's also a place that we have to defend because very often build machines and release machines have the keys to production. So it's a very important aspect to look at in details and protect. So at Microsoft, in the last few years, as you've seen, there's been a lot of transformation, and a lot of it has been around all these pipelines and workflows. So there's been a lot of standardization driven by those attacks that we've seen, but also more regulations and requirements. And when you have these, I believe 15 million of builds that we had, this means a lot of pipelines and workflows in the company. We cannot go ahead and change every single one of them every time there's a new regulation. Recently in the US, we had to make sure that we produce software bill of materials for every single one of our products. And in order to do that, we had to change all our pipelines and workflows. That was a lot of work. And so one thing that we did in order to simplify that and make sure that we're ready whenever there is such a regulation or a new defense that we want to introduce in our engineering system was to standardize on pipeline templates. So we now have a template that is applied at the company level, a 1ES core template that is applied at the company level. That's what allows us to be secure by default. That can be then enhanced by product teams and refined for their own tools at the local level. So in that template, we have all our static analysis tools, all the SDL security tools that we want to make sure run at build time, and all the product teams that have more specific things for their own regulatory environments are also able to do that at their level. And if you remember the demo on StartRight where we were creating those pipelines, again, that happens transparently. When they want to select a starter pipeline, that's where they can potentially select a template that's specific to them, but this will always inherit the global template. Another very important aspect is protecting our build machines and making sure that the right things happen there. And for that, we've put a lot of effort in creating a central infrastructure that's managed, again, by 1ES. We call them 1ES hosted pools, with build machines that are protected, isolated from the internet, have specific subscription, making sure that they're ephemeral, meaning that they're only used for one operations and then they're gone and recycled. And of course, we have things like monitoring, vulnerability scanning, all the defense tools, etc. So this infrastructure, again, is managed and configured at the central level in the 1ES core platform, and then can be further refined by product teams if they, again, have security, special security requirements, want to operate their own. So that's really a theme that you've seen all across this presentation is the ability to have the common denominator, but then the ability also to have local teams specialized. Oh, by the way, this is a product that, an innovation that we created internally, and then that we released to the retail product. It's called Managed Hosted Pools, and available on our products. So again, this is our way of creating things internally, and once we believe that they have value for beyond Microsoft, we will release them. Next, Rajesh will show us how we protect right before the release.
So now let's talk a little bit about deployment, the last stage, right? Our bar for deploying to production is even higher. Production readiness check, or what we call PRC. We have a lot of abbreviations within Microsoft, by the way. So what PRC will do is, PRC will evaluate a set of criteria around the release and the payload to determine the level of risk associated with that payload. Each pipeline that deploys to production needs to go through what we call a production readiness check. What does it entail? First, every commit that's in that payload must have a pull request. Now, as you know, right, we already have a policy which is enforced again across all the 60,000 repos across the company by our GitOps system. The policy is the requiring minimum number of reviewers. So we ensure that this policy is turned on. So second, every PR must be reviewed by at minimum 2 people at Microsoft, something that Carl showed you when he was showing you that GitOps configuration. Now, this 2 people is excluding the author. The PR author is not part of the 2 people. And in fact, in most cases, we explicitly block PR authors from approving their own PRs. Third, as I showed you about the proof of presence, every PR that's in the payload must have the proof of presence attestation, ensuring that that requirement is complete. And finally, the pipeline that's publishing to production must use approved pipeline templates that Carl was talking about as how you can start right with the governed pipeline templates. If any of these conditions are not met, the pipeline run is flagged and blocked. So this is our way of helping us catch issues early, shift security left. So let me show you a quick demo about how the production readiness check work. So here is a pipeline that I have, and I'm trying to deploy this pipeline. Now, it's telling me that, hey, there are some checks that your pipeline didn't pass, so you won't be able to proceed further. So let's take a look at what these criteria are. Okay, it says, oh, a few policies are not satisfied. Okay, let me go and review what that are. All right. So the first thing, as I said, it tells me that the pipeline that I'm using, it's not using the governed pipeline template. So that's one violation. The second violation is I have 4 commits and PRs that does not have the proof of presence attestation. And 3 of those PRs do not have the minimum required number of reviewers. So every pipeline across the company that deploys code to production is checked for these criteria, and if you have not met those criteria, you won't be able to proceed further. There is an option where you would be able to go get a one-time override of these things, but again, once you get an override, you are flagged, and Carl's team and others will follow up with you to make sure that this override doesn't happen again. Extensions. Let me talk a little bit about extensions. Extensions is a great way to add features that are not natively built into Azure DevOps, and they're widely used. These extensions, as you know, can be downloaded from Marketplace or can be built in-house to be shared within our own company. However, it's important to be mindful of the potential security risks associated with these extensions. Extensions can expose you to supply chain attacks. They may access or even leak your data while acting on your behalf. Outdated or stale extensions may contain unpatched security vulnerabilities, making them easy targets for attackers. In some cases, the extensions may be outright malicious, designed to steal, manipulate, or even delete your data. At Microsoft, with a large developer base and a wide range of engineering needs, it's no surprise that we have a broad set of Azure DevOps extensions. But to better protect our engineering systems, we launched a company-wide initiative to systematically review all extension usage with a clear focus on security. As part of this effort, we removed all unused, unpublished, deprecated extensions from the company. We also audited all high-privilege extensions with sensitive scopes such as repo write, or repo manage, or identity read, identity write. Using that, we have significantly raised the bar within the company on using extensions internally. For third-party extensions you download from the marketplace, we took a zero trust approach. Any extension using a high privileged scope was removed. And we paid special attention to pipeline decorators, since these pipeline decorators apply to all pipelines, and you don't have a way to limit their usage. As usual, our ongoing priority is to stay secure. To support that, we have built a comprehensive inventory of all extensions developed and used within the company. We're now enforcing the same production readiness check that I showed you, holding these pipelines to the same high standards we have for pushing code to production. These extensions now are mandated to have code signed. And given the elevated risk around third-party extensions, we are establishing a company-wide allow list so that only vetted and approved extensions can be used within the company. We're almost at the end of our talk. There's one last topic that I want to cover with you. We all have apps and tools that integrate with Azure DevOps, same as extensions. And within Microsoft, as I said, we have a lot of apps and tools that build capabilities on top of Azure DevOps. Some of the GitOps tools that Carl was showing you, they are also apps built on top of Azure DevOps as the core engineering platform. Most of these apps, they act on behalf of the users, meaning that they use a user's token and have access to whatever the user has. Historically, most of them have used Azure DevOps' own native OAuth capabilities. However, those OAuth capabilities is not seeing the same level of investments that Entra has and the improvements that Entra is continuously rolling out. After all, Entra is Microsoft's modern identity system. As part of SFI, we started another initiative to migrate all of these internal apps from using Azure DevOps OAuth to Entra OAuth. And in fact, we are very close to finishing that work. To help with that effort, we brought Entra on par with Azure DevOps OAuth on using granular scopes. Entra now has access to the same set of granular scopes that Azure DevOps OAuth used to have. We plan to deprecate the legacy Azure DevOps OAuth soon, and a public announcement on this topic is forthcoming very soon. Now that you know about the upcoming deprecation, you don't have to wait. If your apps still rely on the legacy OAuth, we strongly encourage you to start planning your migration to Entra OAuth. As you migrate, make sure that your app is requesting only the scopes that it needs to work and not the global all-access user impersonation scope. At Microsoft, any of these apps that are requesting these scopes, they need to go through extensive security reviews. They need to provide information about their usage, and we will evaluate the risk of that particular app before we allow that app and the scopes to be approved. Especially that's what we call the admin consent process. We recommend adopting a similar approach in your company. Depends on your own risk threats and defense postures and usage patterns. So I'm going to turn over to Carl to do a quick wrap up. Thank you, Carl.
OK, so we've seen a lot of things. We've talked about how we operate, principles, and security moments. So let's take a look at these three key things. No matter the size, no matter the scale, it's a team sport, right? Like, we're all participants into security. Every developer is part of the security team. And we have to divide and conquer. Like, one central team cannot do it all. So the advice here is really think and partner with the different teams and see what can be done centrally by like a core team, and what needs to be delegated to local teams, local developers when they think about their own specificities and their own product. The second part is those principles. Shift left, of course, but secure by default, secure by design, secure operation, and the right security at the right moment. And then looking at the entire DevOps cycle. There are opportunities everywhere to both shift left and think about how to integrate things smoothly so that they just work and that the developers don't have to be security experts. And that's really the guideline that we've been operating on, is how do we make this seamless so that it's not a barrier? Because people will find a way, right? Like when you put barriers. So it's really about thinking like that. It's not always entirely possible, but at least we strive as much as possible to do it that way. And then look at your supply chain. Every single element can be vulnerable, can be attacked, and so we have to look at every single part of it to protect it. That's it. Thank you very much. So I think we have 5 minutes for questions. If you have any question, there's a mic here.
Hi, thanks a lot for presentation and very relevant work on pretty much same stuff with large corporation. You switch it between ADO and GitHub. Mm-hmm. So do you have symmetric coverage for both processes on ADO and GitHub, same coverage, or you constantly need to catch up because some teams work on ADO, some teams work on GitHub?
So the majority is on Azure DevOps, but we do have a number of workloads on GitHub. So we have similar security. So it's different. The platforms are different, right? So we don't have exactly the same processes, but we have the same principle. For example, our GitOps platform is there, and all the essential things are there in both sides. Yes.
An extension which you showed to ADO, do you think they will be available for external customers, or are they strictly internal?
The extension capabilities, that the extension is more of a security process and the review that I talked to you about. Information such as whether a particular extension is being used or not, whether an extension is using high privileged scopes, that information is available to all customers. In fact, if you go to your Azure DevOps organization, if you go pull up the extensions setting, you will be able to see the same information that we are seeing today, right? That's right. If you have hundreds of ADO organizations, that is true that you will have to go check the usage of all of that. And that's the scale of the challenge that we are also facing at the company that I was talking to you about. But the data is available to you for you to be able to take your own evaluation of those extensions and take decisions accordingly. Yeah, great question. Yeah.
Hello. So our team uses the on-premise version of Azure DevOps, and I'm curious if all of the stuff discussed here in this talk, is that going to be, I guess, only for the online version or cloud version of Azure DevOps, or will it also be available in on-premise versions?
Some of them are, that's a great question. Some of them are definitely available for the Azure DevOps server versions also. The advantage that server versions have is you still have much stricter control over your Azure DevOps server. Most of the Azure DevOps server instances we have seen is run in a company's own data center, right? So that's why we do not prioritize bringing all of the security capabilities to the server. Of course, cloud is where we want to go protect. The challenges and threats are quite severe in the cloud, and that's where most of our focus on. While not everything is available, some of the policies that I was talking to you about, especially pull request policies, minimum number of reviewers policies, all of that is available in Azure DevOps Server also that you can take advantage of.
Awesome. Thank you so much.
You're welcome.
I think I have one question. So the keynotes had us thinking that with GitHub Copilot and SRE agent, that in the future there's a vision for, potentially agents working together to, discover production issues and then actually commit stuff and roll that out or roll stuff back. How does that vision mesh with policies like proof of presence and things like that?
That's
Yeah.
You want to take it?
Yeah, I
Yeah,
can
go
take
ahead.
that. It's a problem we're working on right now, so very relevant question. There's always an initiator, right? Like even if you have a SWE agent or any type of agent, there's an initiator, someone who triggers it to do some work, for example, assigns an issue to it. And then in that case, there's a bunch of work that is happening, but at some point it will create a PR and someone will review that PR. We are not, at least today, and like for the foreseeable future, letting AI or machines merge those PRs. So there will be a human, and in general, not the human that initiates the work, that will review that PR, and that will review that code. And that's where proof of presence is still relevant. And all the things that we've discussed are still relevant, because even though an AI has been doing the coding work, at the end of the day, all the other policies remain the same, because the last thing we want is an attacker being able to create an issue, doing like the kind of things that they want to introduce into your code, triggering an agent to do that work, and then it's silently entering your code base. Like, you don't want that. So that's why all these policies remain relevant, and we definitely want to have humans, multiple humans reviewing those PRs.
Thanks.
All right,
you.
thank you.
I wanted to ask about SSH keys. You had, in your demo, you talked about personal access tokens, and you showed how to turn those off. You already had SSH keys turned off. But in the world of Git and GitHub, every developer knows how to use SSH keys with GitHub. So how did you get SSH keys out of Microsoft?
So there is already a policy at every organization level. You can turn off SSH keys. In fact, the SSH key usage across the company is completely blocked.
But how did you get there? Because I imagine that at one time it might have been millions and millions and millions of them, right? You never had that at Microsoft?
Not that many,
Okay.
but yeah, just like we're driving down paths, we've driven down SSH keys.
So-
And it starts by putting more and more restrictions. So the best process to do that, you put more and more restrictions on them until developers, and you have to have good alternatives too, by the way. At some point, the balance is not there, and it's not worth using either SSH keys or paths, and the new method is actually more beneficial.
Thanks.
Thank you. I think we need to go out. We'll be outside if there are any other questions. Thank you.